Hello and welcome to today's video. So on the workbench today, we still have the Nissan Leaf battery management system with my microcontroller in there, and I now have code to process the current sensor. So we're now reading that, packing it into the 1 dB hex CAN packet, and sending it over to the pack sniffer, well, the prototype pack sniffer. So I'm faking out the voltage because obviously I don't have any cells hooked up, so I'm just telling it 360 volts, and then the current is live, so I can show you that here. Kind of wish I should have moved that up to the power supply. Anyways, we're putting at 0 amps, and let's crank this up to what do we want to put out. Let's say, let's do 1 amp. We only have half an amp resolution, so we're toggling between there. So yeah, 1 amp. We'll go crank that up to, let's go to what? A little over 3 amps. Yeah, that'll work. And sure enough, 3 amps. So we crank it up to 5. Let's crank it all the way up. 5 amps. And I've got, if you notice, I've got the wires hooked up here so it can go in parallel. So I'll crank it up to, let's say, they're going to start getting really hot. So let's do about 7 amps. 7 amps. And we'll crank it up to, let's go full power. So there's 10 amps. And we've got 10 amps. So it works in both directions. So I'm going to turn this down because my wires are going to get really hot. And so we're back down to 0 amps. We'll go ahead and reverse these guys here so we can do negative. So I got that reversed, and of course we're still putting at 0. And then I'll aim this down here when I turn this up. You can see current going up. There's only 5 amps on the one, and we'll go ahead and turn the other one up. Negative 10 amps on the other. So yeah, I'd say that's working pretty good. I'll turn it back down before I burn up my wires. They actually get really warm. I don't think my clip leads are really, my alligator clips are designed for this kind of current, but yeah, so that's working really well. And just gonna show you, so this is actually live. Like, let me actually run this and tell it to pause it here. I'm actually computing everything. So this is the values here. I even have the keep alive. So, you know, it goes 0, 1, 2, 3, 4, 5, 6, 7, all the way up to F and then resets. And I am calculating the checksum. So this is a 1 dB packet. It's a valid packet. Like, if I actually transmitted this to the VCU in the vehicle in a Nissan Leaf, it would accept this as a valid packet because the checksum is correct. I reverse engineered that. It is polynomial number 85 checksum, so it's an 8-bit checksum, poly number 85, which is exactly the same as what they used to talk to the BMS chips. And if you want to know how I come up with all that, there's a video. If you go back to my Part 12 Solectria E10 lithium-ion battery upgrade, Part 12 has the entire video, shows you how to reverse engineer checksums to get that. So anyways, yeah, it's all working. So I've got to build up the rest of the packets. And it's starting to get a little scary because you could literally take this and put it into a real Nissan Leaf, replace their BMS with this one, and it would actually work. So yeah, it's getting there. Just got a few more packets to build, and then of course get it to start talking to all of these chips, so we can talk to all the balancers, and then we can turn on the balance resistors and be able to read all the cell voltages. So yeah, progress is being made. I'm excited. If we actually had the voltages to compute, I could spit it out here and it would show up. So anyways, yeah, thanks for watching. Bye.